Welcome back to the 1600 game. I'm here with our top math tutor, Yuan, and we're going to go through some questions that Yuan thinks are interesting for most of you students. If Yuan, who is a physics major, is it what is it exactly?
Math.
Aerospace engineering. Yeah. So if he thinks it's interesting, then I'm sure it's interesting for you guys who are trying to get into college. So Yuan, which question are we starting with?
Starting off with a rocket question.
Rocket question.
Yeah.
Classic.
Number 10.
Nice. All right. So here we have number 10. I'm going to read the question. I'm going to do it the same way we teach our students. So I'll start with the last sentence first.
Mm-hmm.
And then after I get through all the material, I just want you to talk to me about what you think is interesting and we'll go from there.
Okay.
All right. On average, approximately how much propellant in kilograms did the rocket burn each second after launch? Now, you might be thinking, why are we starting with the question itself? It's because sometimes on the SAT, you get this block of text and you don't know what to do with it. So as you try to integrate this information from sentence 1, sentence 2, you don't have what you need to actively begin. So it's always good to start with that question. So the actual question is, how much on average did it burn each second after launch? And then we got some material that I'll race through in the first couple sentences. It contained 467,000 kilograms of propellant before launch, and exactly 21 seconds after launch, we have 362,000 roughly of the propellant. So, Yoan, why are we talking about this question? What do you think is interesting about this question?
Well, as you were saying from the last sentence, we know we have to find a rate, kilograms per second.
Mm-hmm.
So just subtracting those two values you just read off wouldn't be enough.
Yes.
And in fact, that's one of the trap answers.
Yeah, right. Answer choice D is just the difference between those two values, which is not sufficient. That's not enough information. Okay, cool. So I'll be your scribe. You tell me what to write down to actually solve this question.
Well, first you do need to subtract them.
Yeah, and we know, here's the beauty of these answer choices. They're so different that it might make sense to actually just ballpark this one, right? And just say it's basically 105,000 kilograms.
Yeah,
right?
about.
Right. So that's good enough, right? That's the difference between the two. And then what else do I do?
Well, then it gives you the time period you burn those 105, which is 21 seconds.
Yeah, cool. 21 seconds. Cool. So basically we're just dividing that total amount by the number of seconds, right? And we'll get our answer. Okay, cool. So this is a good moment to kind of remind students that even though you have Desmos, it's not always the best move to just throw everything into Desmos because, if you're trying to do your best on this exam, likelihood is what 100 divided by 20 equals, right? So we can get to our answer. I hope I'm right. Do you think it's A?
Yeah, it's
all
A.
right, cool. All right, we sound good then. We sound smart.
And then your units also line up because you're dividing kilograms per seconds.
Yeah, very smart to pay attention to that.
And that's like a last minute check you can do.
Nice. Great. And let's also mention that, depending on where you are on the exam, that's how you're going to know how seriously to take those little checks, right?
Mm-hmm.
So if you're dealing with, number 21 in a section of 22 questions, the units are there to mess with you.
Yeah.
Right. So we'll see even more of that as we go through some questions. All right. What's the next one? Sadly, they're not all about rockets for you, but what else are we talking about?
This one's number 12.
Okay, cool.
It's sort of a physics problem.
Okay. I see what you're doing here, dude. I see what you're doing. All right. So why don't you read the last sentence for me on this question?
It says, which number represents the height in meters from which the object was kicked?
Yes. Okay, cool. So the height from which it was kicked.
Mm-hmm.
And, if we look at the previous sentence, the first sentence here does very little for us. An object is kicked from a platform. Fantastic, right? Yes, exactly. So the second sentence gives us an equation and it says that this is the height t seconds after it is kicked, right?
Mm-hmm.
So what is the time at which it is kicked? I know I'm asking you a silly question, but go ahead and answer it for me.
It's t equals 0.
Yeah, exactly, right? So basically this question is, I had a friend who called this kind of thing nested. In other words, like the actual question they're asking you is, what's the y-intercept?
Mm-hmm.
Right? I think that's what they're asking you.
Yeah.
Right?
And it's a very simple calculation.
Yeah. So basically, what do we do to find the y-intercept here?
You plug in t equals 0.
Yeah. Try hard and believe in yourself. You're going to get the answer here, right?
Yeah.
So what is the right answer to this question when t equals 0?
Answer D.
Yeah.
9.
Great. Awesome. So I think that answer choice A is one of the things that people should be paying attention to. Do you have any sense of why that might be the case?
Well, if you make the correct inference that t equals 0, you could
Mhm.
just jump to that answer immediately.
Totally. Yeah.
That happens all the time.
Yeah, right.
When it's like multiple steps, and then you get one answer first step, and then you immediately think that's the answer.
That's it. That's exactly it. Yeah, XY confusion, or in this case, HT confusion, the confusion between, the input and output values is like one of the things that no matter how smart people are, easy to make that mistake, right? So that's what we're on guard for in a question like this. Cool. And of course, I'll let you say it, like, what's up with B and C? How are those relevant to the material?
Well, they're just pulling numbers directly from the equation.
Yeah.
So if you had no idea what was going on,
Mhm.
you could think that's like a sensible guess.
Yeah. Yeah, that's good. Yeah. Cool. All right. What else do you want to talk about here?
Number 15.
Cool. All right. So 15, it asks us for the definition, an equation that defines f, and they give us these two values. So how would you handle this question?
I thought it was interesting because it just boils down to finding the slope and y-intercept, but it's not phrased like that.
Yes.
Which could throw students off.
Exactly. Number one thing we hear people say when they start looking at the SAT is like, the question is just, I don't know what they're asking.
Yeah.
Or they're doing something weird here, right? But basically, anytime someone is dealing with functions, the number one thing we have to tell them, when questions get way more fancy than this too, is just, if they give you values, just, even if you don't know for like what you're doing by plugging the numbers in, just put them in, and the next thing you find out will be of use to you. Yeah. Right. So yeah, we put those values in. Basically, we can look at this too, and we can just say, well, the y-intercept is what? 8. Yeah, and that'll allow us to cross off 2 answers. And then the next question is the slope 12 or is it 4? Now, there's a couple things to say about that. Obviously, we could just calculate, right? And by calculating, we can see that it's 4.
Yeah.
But there's also a couple other things we should ask students to notice, which is the likelihood that the slope is 4 is higher at first glance because there's 3 answers that look that way. Right?
Yeah.
So if you're picking the outlier in a math question, like, just make sure that you are fully committed to that outlier, because there's a reason that 4 is the slope on 3 of these answer choices, right? So it doesn't mean that it's always wrong to pick, 12 in this case, or the one that stands out, but it does mean that, like, if you're picking that answer, you better understand why 4 is there. So I'll flip it around and I'll just ask a question that, I'm sure feels pretty obvious to you, but, I'm picking 4x plus 8. Why do they have 12x plus 8 as an answer?
What, again, with the last problem, they're just throwing numbers directly from the problem into the answers. Yes,
that's exactly right. They're just putting that number in there because it's a relevant value that's been given to us, right? And that's sufficient. If you know why the other answer choice is there, then you're probably in good shape.
Yeah.
Sometimes I'll say to people, like, the number one check if you're doing things right on an SAT math question is, do you know why the other answer choices are there? Put another way, like, if you don't know what the trap is, then you're probably in the trap.
Yeah.
Right?
Yeah.
So, okay, cool. Let's keep going here. What's the next one?
Number 18.
Number 18. All right, so we got a word problem here, kind of a block of text, but read the last sentence for me.
If the company's revenue for one group consisting of adults and children was $1,440, how many people in the group were children?
Yes. Okay, so the first thing I would tell people to do here is to take active measures against mixing up children and adults in your equation, right? And basically, I would just write like a C next to this material, or if I'm writing on scratch paper and taking the digital test, of course, then I'm just writing C and I'm underlining it so that I make sure that I solve for the right thing.
Yeah.
Now, look, we could set up a system of equations here. That'd be cool. But I wonder if we can make any moves to make our lives easier. I'm going to try something. It might be too cute. All right. So we'll see how this goes. Obviously, we could build an equation, but we have numbers for answer choices, right?
Yeah.
And if you look at some of these numbers, like there's 21 people in the group, right? So I'm going to ask you, what is the relationship with answer choices A and D in the context of a 21 person group?
I mean, they both add up to 21.
Yeah.
So
conceivably, if 3 were children 18 would be adult, or vice versa.
Same with B and C, though.
Exactly.
Yeah.
Exactly. So it actually makes sense to start by thinking about maybe just throwing these values in, right?
Yeah.
So like people need to be able to build equations, of course, right? But on a timed test where people are like, dealing with many, many different challenges from the reading section all the way through the math section. By the time you get to like module 2 and the hardest questions, you want to have sort of banked enough energy and sort of like cognitive load remaining to do good work, right? So I actually think in a situation like this, there's something really powerful about just guessing and checking, okay? And people can use their calculators for that. But, if we look at this here, and let's take the average dollar value, which would be $70, okay? Right? If you charge $70 per ticket for 21 people, I know that math is not even close to above you. 21 times 70.
It's 1,470.
Yes.
Yeah.
Yes. Good.
You're really putting me on the spot here.
Yeah, but I know you can handle it. So, okay. So that means that if you had like more adults than children, we would expect a higher value, right? So I'm going to guess to start with that the children are 9. Seems like a good guess. I'm sorry, that the children are 12. My apologies. It seems like a good guess because like we're already saying that if you had like an equal split, like an average cost ticket, then you would be pretty close to our target of 1440. We want to save a little bit of money off of the 1470 that you just calculated on the spot. So I think 12 is a good guess. We could obviously run this through the calculator. I won't put you on the spot for the mental math here again because you have done your service this time. I'll do it myself here. If we have 12 kids times $60, that's 600 and 120 for 720. And then if the remaining 9 tickets are for adults at $80, then that's another 720. And 720 plus 720 gets us our number, right? So look, I tell people all the time, if you're using like an equation to do your work, fantastic, but you should check it in this way.
Yeah.
Right. And if you are trying to move quickly, I actually think it would have made sense, even without my cute little estimation prior to the work, to start with 12 or 9, try it out. If you start with 9, then you'd figure out that you probably need to do more children and less adults because the numbers would be off.
But not off by much.
Right.
If you did A or D, you would immediately know it's
exactly
probably not those two.
Yes. There's this other benefit to starting in the middle on a lot of these answers, which is if you start in the middle, you probably only have to guess like twice, right? Because if you're wrong, let's say that you're wrong that it's 12, right? Let's say you guess that it's 12 and you're wrong. If you know it has to be smaller, then you go to 9. And if that's still too big, then you're done, right? It has to be A, right? So if you're not taking advantage of multiple choice in this way, you're probably wasting your time doing some work or creating a problem for yourself with a system of equations. Right?
Unless you're really comfortable using
systems. If you're like the equation master,
all power to you.
Like, go for it, right? And then use this to check your work at the end. Because now you'll have to check it once.
Yeah.
Right? Cool. All right. Great. What's the next one?
Number 22.
22. Okay, the last one in the section in this big old table.
It's kind of intimidating.
Yeah. Tell me, I'll read it here. Then you tell me what you think is intimidating for the average student here. They give a function, x plus 6 times x plus 5 times x minus 4, all in parentheses. They say the function is given which table of values represents f of x minus 3. Okay, so what do you think's going on that's worthy of discussion here?
Well, first they give you a factored function with 3 factors. Which is not a quadratic, so people might freak out about that.
Yeah, no doubt.
But you don't even have to know like more than a quadratic. You just need to plug in values.
Exactly. So this is precisely what we're talking about. Literally every time you see a function question, they're going to give you some values and you should just try them out.
Yeah.
Right. Now, I did a quick scan through these and I noticed that only B and C have the same initial set of values. The first set of values listed are -6 and -3.
Yeah.
I wanted to check that really quickly because the thing that happens to people is they jump into the first set of values. Test makers know that, and they're likely to create a situation in which, all the answers work or something. You could waste time by starting at the top. So sometimes I like to be a contrarian about things and go to the last set. Okay. So if you look, and again, imagine it's number 22, so it's the last question in a section on the real test. I think on this document we have some more, but on your real test, if you see number 22, you're on your last question. Okay, this is the non-adaptive PDF, so we see all the questions, but number 22 on your test is the last one when you are taking the test digitally. Look, if you're running out of time, the fastest thing you can do on this question is say x equals 4. Whichever one works, if you get, whichever y value is gained from putting in x equals 4, that's the answer, right? Yeah. You only have to test that one number, and that's a powerful move, right?
Because they're different for each answer choice.
Yes, exactly. Now, I'm actually realizing as we say that there's this other level of confusion that happens here, which is they don't want f of x.
No.
Right?
They want f minus 3.
Yes. So let's even go one step further and say, if I look at that fact, I'm wondering if there's like some answer choices that create a trap. Are there any answers that are off by 3? I don't think there are. Interesting. Usually they would have like something like, 4,7 and then 4,4 or something like that, but they don't have that.
Well, it's because when you plug these values in to the function, it just zeroes out.
Yes.
So it results in minus 3.
Yeah, nice. Perfect. So by putting in x equals 4, the function zeroes out. Now, if someone's confused about what we mean there, explain to them what we mean by the function zeroes out when I put in x equals 4, because I'll frame it like a student would maybe. They'd be like, well, but hold on, like I'm getting, when I put a 4 into this first set of parentheses, I get 10, and the second set of parentheses, I get 9. So what do we mean it zeroes out?
Well, in the case of 4, your third factor, x minus 4, that goes to 0.
Yep.
And since that's multiplying everything else,
yes,
it all goes to 0.
Perfect. So a mistake we'll see sometimes is people expanding this equation out, right?
Yeah,
like
you don't want to
do not do that. You want to take advantage of factors. Every time you get factors, take advantage, right? So when x equals 4, we know that f of 4 equals 0, right? And then the chart asks us for f of x minus 3. So to your point, when x is 4, what does y equal?
0 minus 3,
yep,
which is negative 3.
Boom, and we're done with the problem in that case, right? By just trying out that one value. Whereas, now that we see that the answer is B, you can recognize that the first set of values, negative 6, negative 3, would be valid for answer choices B and C, right? And there may even be more. Yeah, so for instance, if you look at answer choices B's second set of data, that matches the second set of data in D as well.
Yeah.
And I could even imagine why someone would put negative 6 positive 3. And I'll just say that really quickly. You know how when you make shifts to the left and right, how is that counterintuitive compared to the way you make shifts up and down, how you express those algebraically?
Because when you're moving around x, you're doing the opposite of what you're manipulating x by.
Yes, exactly.
So they might apply the same logic to y.
Totally.
Giving them positive 3.
Yeah, exactly. And if you're trying to master this test, one of the most important things that we can impart to you is even when you get a question right, your work is not done as, a student of this exam. If you want to master this material, you have to know what your opponents are doing all the time. And in this case, we're noticing that the translation up and down by 3 units, looks a little different on the page than horizontally by 3 units. When you notice that, you're more ready for the next trap, even if this trap wasn't the kind of thing that would, make you stumble. So, okay, sweet. We did that question. I think we did it pretty efficiently. What's the next one you want to do?
Go to module 2.
All right.
Number 5.
All right, we're getting into it now, module 2. So, okay. So we've got a question with a ton of exponents here.
Yeah.
And number 5. So what kind of mistakes do you think are likely to be made on a question like this?
Multiplying them instead of adding them.
Yes. Yeah.
But this is just a question of knowing your exponent rules.
Totally. Yeah. The other thing we could say about this is sort of divide and conquer, which is to say some people are going to bury their head in the calculation and complete the calculation. But you and I can see that if we just think about m, right? It's m to the 1 power on the, is the second one, and m to the 4th is the first one.
Yeah.
Right. So of course that's going to result in m to the
5.
Yeah, m to the 5, right? And sometimes like one of the biggest things we can do to help people that with if they don't know their exponent rules, if you're like going into this test and you're struggling with your exponent rules, it means somebody has like failed to help you understand something fairly simple here. And that's perfectly okay. Like there's all sorts of kinds of, gaps that people experience for any number of reasons, right? So one way that I'll teach it to folks is I'll say, well, like, that m to the 4 just means m times m times m times m, right? And then we'll do one more for the next, m, right? So if you could see that there's 5 m's, it's easy to tell that we're talking m to the 5th. I'll admit that the first glance at this, I thought it was going to be m to the 20th power because I just misread the second one. Could you guess the way that I misread the second set of m, q's, and z's to think it was m to the 20th?
No, enlighten me, actually.
Yeah, how could you be so stupid, Jeremy? So it's because the 5th power next to the q, I just, quickly glanced over. I saw that 5th power, but I kind of misunderstood where it was connected. And then if you made the mistake of multiplying.
Oh, you're saying it like distributes to the
like I've seen that kind of mistake. Like if you think that 5 is attached to the m and then you think you're multiplying or something like that.
Yeah.
That's the kind of mistake that we see all the time, right? So, okay, cool. Knowing your exponent rules, we're good on that one. So I would say the only other thing about that question is you could use the rest of it to just check your work, right? That it should be, q to the 9, yes, and should be z squared, right? Yeah. So divide and conquer is kind of the approach there.
So there's not really a trap answer here.
No,
except I would D.
Yeah, D, and it's only a trap if you are uniquely confused like I was for a second. I think that this is a good example of the difference between a number 5 and a number 22, right? And if you crushed module 1, then you may have, of the 27 possible questions, if you're only seeing 22, right, then this question may not even be present for you, or it may be number 1 or number 2, right? And people should have a different experience when they're looking at questions at the beginning of a test versus the middle or the end, when they like what they should expect the test makers to do. So cool. All right, what's the next one you want to see?
Number 9.
All right. So we have, I'll tell you what I noticed here, and then I'll let you kind of take charge of this question. The first thing I notice is how different these answer choices are, right? That like these seem wildly different.
Yeah.
Right. So the distinction between these answer choices is so big that there has to be some other way in which they're closely related, right? There has to be some way in which these numbers relate to each other such that they're not just an arbitrary set here. Okay, cool. So I'll read the question and then you can tell me how to do it. All right. According to the model, about how many gallons are used to drive each mile? And I'm going to make sure that I know it's gallons per mile for answers here. And the first sentence tells us that we have a function that models the number of gallons of gasoline that remain from a full tank in a car after driving m miles. Okay, so how do we do this question?
So like the rocket problem from the last sentence, it's asking about a rate.
Yes.
And that in terms of an equation usually means the slope.
Yes, indeed. Yes.
But we can digress immediately to the traps they're giving you here.
Yes. Tell me about the traps.
So B is the y-intercept.
Yes. So what does that represent in terms of this question?
It's the number of gallons that you start with.
Yes. Very good.
The 0th mile.
I guess. The 0th mile. I like that. Yes. Okay. What else?
And then I think D is the x-intercept.
D, that does sound like the x-intercept. Like when is y 0? I think you're right. Because
like the range of the car.
Exactly. Yeah. Because if we were to say, and I'll write this out, if we were to call y 0, by the way, there's always this confusion between what an x-intercept is and a y-intercept. Like, it's not that that's a conceptual issue. It's that in real time, when you say y-intercept, recognizing that means x equals 0, that's an easy thing to stumble over. And I see it all the time when it comes to an x-intercept, right? People are so locked in with y-intercepts, but people mess up x-intercepts all the time, right? So I like to say, take active measures. So what I'll do for an x-intercept is I'll literally draw a bad Cartesian plane and I'll put like any arbitrary dot that looks like an x-intercept, because visually, like the phrase x-intercept literally sounds like what it looks like, right?
Mm-hmm.
But algebraically, it's a little bit more confusing, right? So it's easy to say where is an x-intercept, like it's on the x-axis, right?
But it's not x equals 0.
Exactly. Yeah. And we should take those things seriously. But yeah, I agree with you that if we made y equals 0 at the x-intercept, that it seems like if we were to I guess we'd subtract 12.1, for instance, and then we divide by negative 0.05. And I agree with you. That's exactly how we're going to get answer choice D.
Yeah.
Cool. What else is there to say? Do you know notice anything else about this question, or does that feel like that's about it?
I think because they throw like the 12.1, even though you don't need it at all. After reading the last sentence, you just need the slope, which is negative 0.05.
Totally. Let's talk about how students can like recognize what like felt pretty intuitive to you. Like you were like, they're asking about the slope, right? So, first of all, let's mention that when it gets to maybe some more advanced questions, like a question about acceleration, that can be confusing because sometimes a rate, like a speed, is not like the same thing as the slope of a question, right?
Yeah.
Right. If you have like a linear acceleration situation, then the rate of the equation is the acceleration, meters per second squared or something like that, right? So what else? I have a very specific approach to this. Okay, so allow me to digress for a moment. Okay, I call this the wise ass answer method. Okay, so here's the wise ass answer method. When you're asked a question like this, you break it down in a tediously small way. And this comes from me being in high school and having a teacher who was really leaning on me to be like the person who would answer. I'm sure you've had this experience, like being in a class and the teacher's like, Yoan, you're great. Like, please help me maintain order in this class by answering questions for me, right? So the situation that I experienced in high school was, me being a total jerk to a teacher in a moment like this. And I feel badly about it. I've never forgotten it. But now it's a teaching tool. So the last sentence says, according to the model, about how many gallons of gasoline are used to drive each mile? And if I were asked that question, I might say something like, well, it says the word each, so it's a slope. And then someone would say, well, like, what is the slope? And I would say it's rise over run. And then I would say, well, what does that mean? Well, it's the change in y over the change in x.
Which here it's the change in gallons.
Yes.
Or the change in miles.
Yes, you did it, right? So, that last step, right?
Yeah.
Then you put it into the language of the question, right? Okay, cool. So a good indicator of this, to start with, and this isn't enough to be like ready to completely just nail every single question on the test, but it's a really good starting place, is to just, sorry, I'm trying to move something out of the way here. A really good starting place is to just say that, okay, if we see the word each, we're dealing with a slope question. Almost certainly, right? Like at the level from 750 to 800, watch it. But if you're like aiming at 700, you could just assume the word each is referring to a slope basically every time. Cool. All right. What's the next one, Yuan?
Number 10.
Sweet. All right. So why don't you read this one off for me?
The given equation relates the positive numbers b, x, and y. Which equation correctly expresses x in terms of b and y?
Yes. So one thing I've noticed students mess up here is they just don't know what it's asking. So what does it mean to express x in terms of b and y?
I guess in the simplest terms is to solve for x.
Yes, exactly. Effectively, it just means, solve for x, get x by itself.
Which even if you're confused by that, if you look at your answer choices,
yes,
you probably know you have to solve for x.
Perfect. So it just reminds people again that like, not even when you're in doubt, basically every time the answer choices should be a part of your approach. If they're there, you should make them a part of your approach.
And I would recommend, looking at the answers before you start doing the question.
Yes. And then let me also give people just a little brief hack here, something that you definitely already know, but it's something that's worthy of our attention. In this case, we're just trying to solve for x. Okay. But I want to say that if you are trying to solve for something that's in the denominator, like y, there's a really fast move. I call it the Eve rule. There's a wonderful student from back in the day who used to yell at me for taking my time on this kind of thing. But basically, you can switch the numerator on the left with the denominator on the right, of course, right? So if you want to get something out of the denominator, that's an easy way to do it. In one step, you could say, well, like y over 7b equals 11x over 1. Right? So that's just like, I know that's the same level of hack as cross multiplication, right? It's two steps in one, but it's just worth saying here. Here, it's not so bad, right? What do we have to do to isolate x?
Well, you can do it two ways. Whenever I see fractions, I do like the crisscross trick. Where the diagonals are equal to each other. So you get that y equals 7b times 11x.
Good. And in a certain respect, that's almost more work than you have to do.
Yeah, it's just
right? It's
just how I always do it.
Totally. Yeah. So, basically to isolate, the way that you've done it is great, and then you would just divide by literally everything other than x. Yeah. So it's really just two steps anyways, right? So basically what we want on the top is y, and we want everything else on the bottom. And I guess that's answer choice C.
Yeah.
C. Sweet. Awesome. This is a question that people should just be able to do straight up. But when I first saw it and I saw all these variables, the first thing I thought is, if you don't know what's up on a question like this, throw numbers at it. Right? You could call x2, and then you could call y something too, and you could just kind of do that work.
That's a good trick.
Yeah, and when you really
I
need
used it on my last engineering test.
Oh, nice, awesome,
and it saved me.
Still crazy after all these years.
Yeah.
All right, let's keep moving here. What's the next one?
12.
12. All right. So 12 says, which of the following could be the value of x? We're getting into it now. Whenever I see that could. Why do you think not asking what is the value of x, but what could be the value of x is unsettling for people?
Because usually we're used to like x is this value, x equals something. But here it's like a conditional thing.
Yes. Yeah, exactly. That feels...
Which people aren't usually comfortable with in math.
Yeah. It's like they're used to getting that there is one right answer instead of, a set of answers. Of course, on inequalities, that's not the case ever. Right? Yeah. Or usually. Okay. So which of the following could be a value of x? All right. So I don't know, man. How are you going to approach this question?
Well, the first thing I do is they give you a point and an equation. I would split the point into x equals x and y equals 53.
Cool. Y equals 53.
That's usually it's easier to grasp.
Yeah, totally. So y equals 53, and then we just go back up to the top here, right? It's like, I suppose what you would do is first say that is y equals 53 possible in the first inequality, and of course it's true.
Yeah, so you can ignore the first
inequality. So this literally doesn't matter anymore.
Yeah.
Okay. And then the second situation, what are we going to do with 4x plus y is less than 18?
Well, then you just have to plug in the values of x that they give you.
Yeah, so 4x plus our y value of 53, right, is less than 18. I think we have to do that, right? Do we have to put the y value in there? Make y 53? Yeah. Okay, cool.
Because y still equals 53.
Totally. And so at this point, we could just even solve 4x is less than whatever 18 minus 53 is 35, negative 35, is that right?
Yes.
Negative 35, I believe. And then x is less than negative 35 over 4, which is not a nice number, but it's pretty close to 9. Right? Okay, so there is one last trap here, and it has to do with inequalities and negative signs. What do you think people mess up a lot with inequalities and negative signs?
They forget to switch the direction of the inequality.
Yes, exactly. And so, of course, the answer should be -9. We need something to be sufficiently small, right? So these basically, if you a good way of checking this question is to go back to maybe the level of 4x plus 53 is less than -18, and then just say, okay, well, we're going to have an x value be sufficiently negative to take our value of 53 on the left-hand side, and diminish the total on the left, right?
Or you could just plug it in directly. Like
Yeah.
4 times -9 plus 53.
And just confirm it.
I'm not sure what that is off the top of my head.
But whatever it is, it's right.
It'll be less than 18.
Yeah, exactly. Awesome. I think it's 17 actually. But we'll keep moving here. Let's see. What's the next one?
15.
15. Okay. So yeah, this is a really good one. This is a really good one. Okay. So I want to ask you about this like x is greater than 7 thing first. Okay.
Mm-hmm.
So, obviously I think that's probably pretty clear to you why that's a limit or a limitation on the domain.
Yeah.
Right. So explain to folks who don't recognize it right away what's going on there.
Well, if you plug in x equals 7 to the denominator, you'll get 0.
Yeah. Exactly.
Which is not a valid expression.
Yeah. And look, so basically they have to include that so that you can't, write in on your form, hey, actually, you guys are wrong and there's an exception to the rule here.
It doesn't actually change the problem at all.
Yes. And that's my point for students is that they really need to be conscious of the fact that like you basically don't care about that.
Yeah.
Okay. So like people will really try to sweat what that means. But there's no good reason to do that.
Mm-hmm.
All right. So tell me how you would approach this question.
Well, the first thing that jumped out at me is the x minus 7 factor at the top.
Yes. Okay. Say more.
So what they're trying to hint at you is to factor the bottom
Yes.
in a similar way.
Yes. Okay. So I'll do that. We have 8x times x minus 7 minus 3 times x minus 7. And then let's factor the bottom. If I pull an x minus 7 out of that bottom expression, what is left?
2.
Wonderful. All right. So now we can probably see the answer if we're savvy on factoring, right?
Mm-hmm.
Which is basically that these terms, x minus 7 all over the place could essentially be factored out all the way out, right? So that everything could just simplify to what, answer choice B?
Yeah.
Nice.
Because it cancels out from the top, the x minus 7.
Yes. So I love how you noticed this as like you used the context of the way they gave you the question to you took the hint, in other words.
Yeah.
Okay. So something we can teach people though that is really, really helpful for our students is like if you don't see that, you can still get points here. Okay. So like if we're working with somebody who's at like 550, hey man, maybe success is 620. You get to 620, maybe you get some scholarship, and that's literally the point of this test is to just, the most important thing is you get the score that helps you get into school, right? So I think it's really important for us to not be like the ones who are like, well, you better know how to factor if you're going to college. You better be the factor. Maybe you're not going to go, maybe you're not studying math, right? So in which case you could say to somebody, I don't know, man, like put in x equals 10.
Yeah.
Right?
Yeah.
Like if you just put in x equals 10, we'll do it really quickly. So basically I tell people this all the time. If there are variables in your answer choices, your Swiss Army knife is throw numbers at it, just like our aerospace engineer did on this test last week in college, right? So if we did x equals 10, it's going to be a little bit of work, but also the power of picking something like 10 is it's not that much work, right? 8x would be 80. Right?
Yeah.
Terrible handwriting. We get it 80. And then 10 minus 7 would be?
Are you looking at the answer or the?
I'm looking at the original expression.
Oh, okay.
Right. So if we put in, if I had no idea how to attack this question, I just put x equals 10 into the original expression. Right. I get 80 times what? 3. And then minus 3 times 3. And then on the bottom, I would get 20 minus 14, which is 6.
Yeah.
So that's, you could use a calculator, 240 minus 9 over 6. And that's going to be 231 over 6. I know a little hack about dividing by 3.
Don't.
Okay. So it obviously isn't important for aerospace engineering. You guys aren't worried about hacking divisible by 3. But for the GRE and the GMAT, you'll want this rule that if you add together the digits, then if the sum of those digits is divisible by 3, so is the original
interesting
number. So 231, 2 plus 3 plus 1 is 6. That's divisible by 3, right?
Mm-hmm.
So of course you could be using your calculator at this point to finish out that question. But what does that equal here? 231 divided by 3 is 60 plus
67.
nice. Yeah.
Yeah.
60 and then I think it's 77.
Oh yeah, 77.
77.
My bad.
77. All good, man. Put you really on the spot that time. 77 over 2 would be the simplified form, and that is answer choice B.
Mm-hmm.
And look, if I had picked x equals 8, probably 2 answers would work because we'd be simplifying x minus 7 to just a 1, right?
And a trap here would be trying to expand out the top.
Great point.
And that's where C and D come in. Because they have an x squared.
Yes, very, very good.
But again, if you're seeing x minus 7 twice, it's kind of screaming at you to do something with it.
I completely agree. And, another approach that you can teach people here is to divide and conquer. So in other words, like if you just say, okay, well, like what's the final term, right? And if you distribute this 8x to the negative 7 and the 3 to the negative 7, it does become clear that like your final term is neither 14 nor negative 77, right? So at that point, although, at least you could say then it has to simplify because you would get your 8x squared by, distributing the 8x, but you're not going to get the other things, right?
Yeah.
So that divide and conquer approach is super useful too. Sweet. All right. So there's that question. We did a bunch of stuff there. What do you want to do next?
That's all I had. Those
Sweet.
10 questions. But...
Awesome. Well, let's leave it there. That was a lot. So thanks for your help, man. I think
of course, anytime.
Covered a lot of stuff. And if you want to see Yoan or me for some test prep, come to the SAT lab, join us, and we'll cover any questions that you want to talk about. Thanks. See you next time.
See ya.